Hi, welcome to HashiTalks 2024 and my talk on mastering Terraform testing. So if you have been following the HashiCorp community during the past few months, you've probably heard a lot about and seen the Terraform test framework. So this is available since Terraform 1.6 and it was recently enhanced in Terraform 1.7. So today I want to go through a layered approach to testing complex infrastructure with the Terraform test framework. My name is Mattias Fjellström. I'm a cloud architect consultant working at a company called Solidify. I'm based in Gothenburg in Sweden. I'm a HashiCorp ambassador since 2023, and I recently started up a HashiCorp user group here in the Gothenburg area. So if you're based here, feel free to reach out. All right, before we dig into the test framework, I want to set the scene a little bit about what I will be talking about. So imagine you and I are part of the platform team in our organization. We're building a platform for our developers, mainly using these tools. We have Terraform Cloud, we have GitHub, and we have Azure. So to illustrate the test framework, I will be concentrating on these 5 modules that we have created. So we have a resource group module. A resource group in Azure is a container for other resources. So whenever you're creating a resource of any kind in Azure, you need to place it inside of a resource group. Then we have the network module, and this sets up a virtual network with any number of subnets. We have the AKS module. AKS is the Azure Kubernetes service. So this module creates a Kubernetes cluster for us. We have the Kubernetes platform module, and this module configures a given cluster according to our specifications. In this case, it installs Argo CD, because later we want to use Argo CD for deploying our applications using a GitOps approach. Finally, we have the Traffic Manager module, and the Traffic Manager is a DNS load balancer service in Azure. All right, so as I mentioned, we have a number of development teams that are using our modules. So of course, we should include testing for our modules to make sure that we're not breaking anything for our developers. So, testing in layers. I'm thinking of a layered approach to testing where you can think of each layer as complementary approaches to testing. So you can pick and choose what layers you want to use. So the first layer is validating Terraform configuration. So this is technically not testing. This is using validations declaratively in our modules just to make sure that the module is easy to use and can be used correctly. Once we have validation in place, we can start adding tests using the test framework. So this is a good place to start by verifying the validation we included in the first layer. Next up is starting to test your modules together where you have dependencies between them. So for instance, in our case, all of our modules basically depend on the existence of a resource group. So there's always a dependency to a resource group module. Taking it one step further, we can start thinking about testing end-to-end scenarios, like where we might have multiple modules involved to set up some sort of scenario that we can imagine. And finally, once you have all these kinds of tests in place, you might also want to start thinking about adding policies code. So this is not either testing in the traditional sense, but as I will show you, sometimes you might realize that some of your tests should actually be turned into policies instead of a test. All right, so that brings us to layer 1. So before we test, we validate. So we had a number of options available for validation, available before Terraform 1.6. So mainly you can categorize them into 2 groups, CLI commands and custom conditions. So the custom conditions are what I refer to as declarative validation. So we quickly go through these different options just to show you what they are, unless if you haven't seen them before. So first of all, we have the CLI commands. We have Terraform init. So if you have ever used Terraform, you know that Terraform init is the first command you run to be able to do anything else. So this command can actually capture the most trivial of mistakes you might make. For instance, you're using a wrong version of a provider that doesn't exist, or you're using a provider that doesn't exist, for instance. Next up, you have Terraform validate, and this can actually start validating your configuration against the resource schemas. So it can tell you things like you're forgetting a required value or something like this. Next, Terraform plan. And this is, I would argue, the most important command available in Terraform. So Terraform plan takes your current state and your configuration, and it says if you apply this configuration, this is what will happen. All right, this brings us to the declarative validations. So for our variables, we can include validation blocks where we can specify certain conditions that the value should fulfill. So this allows you to make sure that your module consumers are providing good values for your variables. We can include precondition blocks for our output values. So this allows us to put up guarantees for what the output value will fulfill if all the preconditions pass, basically. We can have custom conditions when it comes to resources, and this allows us to hook into the life cycle of a resource. So we can have conditions that are checked before a resource is created, or we can have conditions that are checked after a resource is created. This is also true for data sources. Finally, we have check blocks. So check blocks allows us to make assertions not really tied to any life cycle of any specific resource or data source. So in this case, we have set up a website using a module. This website has an endpoint, and we're using this check block basically to make a request to the endpoint and make sure that the website is responding. All right, this brings us to layer 2. So once we have all these validations in place, we are ready to start using the test framework. So when it comes to testing your module, you want to test your module interface. So let's just quickly go through what's involved in the module interface. So of course your module will or should have or might have variables. So variables are the first thing that your module consumer will encounter. So you should make sure that you have tests that verify the behavior of your variables, basically. Our modules might have outputs, so we want to have tests to validate output that our module is producing so that it fulfills our expectations of outputs. Our module has resources and data sources, so we might want to include tests for these our various resources. This depends a little bit on what kind of resources you have and what you want to check. Many of the tests that you include in this category will actually be tests for your provider. So is the provider you're using actually behaving as you expect? We might also want to include tests for functionality and behavior. And this is related to, for instance, the check block I mentioned. So if we have set up a website, we might want to have a test to make sure that we can reach the website once it is set up. We could also include tests, for instance, a more advanced kind of tests where we maybe upgrade the Kubernetes version in a Kubernetes cluster. So we have a module specifically for that, so we can make sure that once we have upgraded the cluster, it behaves as expected. All right, so that brings us to the first look at some code. So we'll jump into Visual Studio Code. And what we're looking at here is the resource group module. So I won't have time to show you all the code, but basically what it consists of is this single resource called the resource group. My module has a number of variables. So I have a location variable. This is basically the Azure location where I want to place my resources. In this case, I've included one validation block that makes sure that I'm only allowing one of these three values for this variable. I have two other variables, one for name suffix, which will be appended to the name of the resource group, and I have a map of tags. So as we can see, all of these validations I've included here, we would like to actually make sure that they behave as they're supposed to do. So this is what I've done in one of my test files. So this, you've probably seen this before. This is a test file. I'm configuring my provider, and then I have a number of tests that actually make sure that the validation of my variables behave as it should. So let's just pick one test just to illustrate what happens. So for instance, this one should not allow invalid locations. So if I provide a location that I don't expect to be allowed, I'm expecting a failure in the location variable. We will come back to this in the fifth layer when I talk about policies, because this is one of those occasions where this shouldn't really be a test, it should rather be a policy. All right. I want to highlight that I'm using a feature here, one of the new features of the test framework. I've placed variables inside of a tf-vars file. So the test is using these variables, so I don't need to define them in my test file, except if I want to override any values, for instance, like I do here. Okay, let's jump back to the presentation. Right, so layer 3. So in reality, our modules do not exist in isolation. Most likely you will have dependencies between different modules, or you might have dependencies to third-party modules and so on. So this brings us to integration testing. So in our case, we will look at this specific example. We have the network module, which requires the existence of a resource group. So this is common when you're working with Azure. I mentioned that the resource group must exist, and you must, all of your resources are placed inside of resource groups. So when it comes to dependencies like this, you have a number of options. You can use the published module if you're in control of both of these modules. You could set up helper or setup modules just to specifically create the kind of dependency you want. You could use hard-coded values, or you can use mocks starting in Terraform 1.7. The problem with the last two options are that it might not be possible to run apply operations if, for instance, in Azure, since the resource group must exist, so you can't mock away and create a network inside of it. All right, so we will look at some code, jumping into Visual Studio Code. So in this case, this is the network module, basically. So what it does, it creates a virtual network, and it creates a number of subnets in the virtual network. The important point to note here is that this virtual network requires this resource group, which appears in a variable. So how to handle this? Let's look at 3 different examples in our tests. So first of all, I configure my provider, I configure my global variables, and next I set up my dependencies. So here I'm using my published module. So I'm referencing the module in Terraform Cloud, my private registry. I'm providing the required variables, and then I create the resource group. And then in the following tests, I can just reference the resource group like this. The second example here looks very similar. I configure my provider, I configure my variables, but instead of using the publish module, I'm just using a simple helper module that I set up. So this just creates a very basic resource group, just enough for me to do my following tests. The third example I want to show is using hard-coded values. So in this case, the difference here is that I configure my resource group as just hard-coded values like this. What I won't be able to do in this case is run tests that have command equal to apply. So all of these tests are just plan tests. All right, I want to show you one more thing. So we'll open a different repository. All right, so here I have a fairly simple repository. I have a main TF file, which is just contains the Terraform block. So this is a module specifically used for testing, and it has no other purpose. Inside of my test directory, I have nothing currently, just a git keep file. But in my template file, I have a template directory. I have something that looks like a test file. So I have two run blocks. The first run block creates a resource group using the published module, but I'm not specifying a specific version. Instead, I have this template expression. It's a placeholder for the version number. Likewise, I set up my virtual network in the second run block, and likewise, I have a placeholder for the version of the network module. All right, so I will run these tests inside of GitHub using GitHub Actions. So I have set up a workflow file. And in this workflow file, I'm using this sort of strategy where I'm specifying different versions of my modules. So for my resource group module, I have two different versions, and likewise for my network module, I have two different versions. So what will happen when I run this in GitHub, we can just jump into GitHub. And if I go to my actions and then we look at the last run, we see that I have 4 different jobs. So the R here stands for resource group and the N stands for network module, basically. So we see that for each permutation of the different versions of my modules, one test is run just to verify the compatibility between the different versions. All right. Okay, so layer 4, testing all the modules. So imagine you have any number of modules that your users can use in any way they want, but you have some intended workflow of how the modules should fit together. So in that situation, you should add tests to verify that they do indeed fit together and work together as you intend. So here we have an overview of what an example, a demonstration I want to do. So it's not an architectural drawing, it's more like just to show you how different components fit together. So the outer box is my resource group, and inside of my resource group I have a virtual network, which is the inner box. Inside of the virtual network I have 2 Kubernetes clusters. Each cluster is running Argo CD, and each cluster will also have a sample application deployed. In front of the clusters, I have a traffic manager, which is the DNS load balancer. And as part of the test, I want to actually send requests to the traffic manager and see if I can get a response from the applications running inside of Kubernetes. So this type of test is generally involves like complex infrastructure and complex operations. So in this case, we have multiple clusters. We can imagine that we could even maybe be using different cloud providers, having a cluster running in AWS, one cluster running in Azure, and so on. We will perform some complex operations as well. I will first of all enable one of the clusters so that when I send traffic to Traffic Manager, I will be directed to my first cluster. Then we will switch so that the second cluster becomes the active cluster, and I will send another request just to verify that now indeed the second cluster is responding. Okay, so to do this, I have this repository. So this is once again just a dedicated test module. So my main TF file just configures what providers I'm interested in. But the main work is done in my test folder. So I have this end-to-end tftest.hcl file. And there is a lot going on in this file, so we will just look at a few things to understand how it works. So I'm configuring my provider. I'm configuring a common variable, which almost all of my modules require. Then I'm running through some setup steps. So I'm setting up the resource group. We have seen this before. I'm using my published module. Then I set up my virtual network, once again using my published module. Next up we have one complication. So this has to do with how the test framework actually works. So if I have a run block which references a certain module, and then I have a second run block which references the same module, then the same state file would be used in both of those cases. which doesn't really work if you want to create 2 AKS clusters using our AKS module. You can imagine the first run block would set up a cluster, the second run block would destroy the first cluster and set up another cluster. So to get around that, we need to use a helper module, and I'm calling it cluster. It looks like this. So basically it creates the 2 modules for me. So my first cluster and my second cluster using my published AKS module here. And then it just outputs whatever values I require from the modules. All right, next up, I have the same issue when it comes to setting up the Kubernetes platform. So this is basically when I install Argo CD on my clusters. So likewise, I have a helper module that performs the job for me. Once that is done, I'm configuring 2 providers. So this is a feature available in Terraform 1.7 that you can actually configure a provider with output coming from earlier run blocks. So this allows me to configure a provider for each of my clusters. Next, I have a helper module to set up applications for me. And this is the same issue as with the cluster, so I can't directly call the modules in my test file, because then they would override each other. So I'm using a helper module that sets up 2 applications. Next up, I want to figure out what is the IP of my applications, because I will require the IP addresses when I next set up Traffic Manager. So let's just quickly look at this service IP helper module. It's using the Kubernetes provider, the Kubernetes service data source, to query for the IP address, basically, of each of the applications. And then it's outputting the IP addresses. With that information in hand, I can set up my traffic manager, and the important point here is that I'm setting up 2 endpoints. So one for my first application running in cluster 1 and one for my second application running in cluster 2. And we can see that I'm enabling the first endpoint here and disabling the second endpoint. I'm using my published traffic manager module. And next we come to maybe the first actual test. So we're polling traffic manager and making sure that the application running in cluster 1 responds. So I'm making sure that the response code is 200 and that the response content contains this hello HashiTalks 2024 version 1. Next, we want to update the traffic manager to instead point at the second cluster. So I'm using the same traffic manager module as before, but this time I'm disabling the first endpoint and enabling the second endpoint. Once that is done, I'm making sure that if I send a HTTP request to my traffic manager, then indeed I'm getting a response from the second cluster. So the response code should be 200, but this time the response body should be hello HashiTalks 2024 version 2. So running this test takes quite a lot of time, but if this is the intended operations my modules are supposed to support, then of course I should have tests for it. You might not want to run these tests every day and like test all the different permutations of versions, because it would take a lot of time, but you need to define what strategy makes sense for you, basically. Okay, so this brings us to the 5th and last layer. So some things are not tests, some things are policies. So remember the resource group module I showed you in the beginning? We had this variable called location. And for this location, I had this validation block that made sure that the provided value was one of 3 allowed values. So imagine you have the same validation logic in all of your modules. You can imagine that it doesn't really scale that well. So if you need to update the validation logic, you would need to do it in all of your modules. And you might also realize that if you have teams deploying from Terraform Cloud like this. They are using your organization modules, everything is well. But in reality, it looks more like this. So they are using your published modules, they are using their own internal modules, they are using any kind of third-party modules, and they are using just plain old resources in the root module. So of course you want to have the same sort of validation logic going on no matter where the resources come from. So to do that, we have two options since we're using Terraform Cloud and we're using Azure. We might want to place the policies inside of Azure and use the native Azure policy service. And it's a valid option, you can do it. However, it doesn't really play that well with Terraform because Terraform might not be aware of these policies before you actually run an apply, and then you will get an error message. So a better option would be to put the policies inside of Terraform Cloud. And you can do this either using HashiCorp Sentinel policies or the Open Policy Agent policies. All right, so we'll take a look at what this looks like. I have a simple policy here. So inside of a repository that I've connected to Terraform Cloud. So this lists, this is a policy for allowed locations. So we see I have a variable here for my allowed locations and the same values as in my validation block. Then I'm filtering out all the resources coming from the Azure RM provider that is about to be created. Next, I go through all the resources and just make sure that the location is in the list of allowed locations. So that's the policy. If we jump into Terraform Cloud, we can see that I have a workspace. So this is a team workspace. And they have recently created some change in their infrastructure. And we see that since I've connected my Sentinel policies to this workspace, after a plan has finished, we see that Sentinel policies kicks in. And in this case, we see that there was some violation. So allowed locations failed. And this is basically because if we expand the plan here and we look at one of these resource groups, see that the location was East US. So this is the resource that was not allowed and hence the policy failed. So this is a way of actually scaling these kind of validations to cover, like, no matter where this resource comes from, if it's your organization modules or any other third-party module, you get the same validation going on. All right, so that brings me to the summary. So if you take one thing away from this talk, it should be test your Terraform modules. But you can start fairly easy, and I would suggest, unless you already have a lot of validation going on in your modules, you should start there. So add validation for your variables, your outputs, your resources, and data sources. So basically validate anything you can think of. Once that is in place, you can start adding tests to verify your module interface. So start with your modules in isolation, one module each, just one module in isolation. Next, start thinking about how your modules fit together and start adding integration testing for your modules. Next, if you have any complex idea of how your modules should fit together that you want to support, you should add end-to-end tests just to verify that they indeed do work together, like completely. And next, use policies where it makes sense. So everything shouldn't be a test. Some things should be policies. All right, thank you. That was everything I had to share with you. So all the code that you saw today and much more is available on my GitHub. You can visit my blog if you like, matthias.engineer. I write about Terraform and other things as well. If you like, you can add me on LinkedIn. And if you're based in the Gothenburg area, I suggest you go to this meetup link and join the Gothenburg HashiCorp user group.